All right, in today's lesson, we are going to determine sampling methods. We are going to learn the difference between categorical and quantitative data. We're going to analyze some graphs and we're going to work with some frequency tables. So the recall is taking us way back, probably elementary school, when we're doing proportions. So it says what is 15% of 60? So is over of equals percent over 100. So what is, so that's going to be the x, 15%, so that's going to go in the percent spot, and then the of is 60, and then we're just going to solve that. So we can do cross multiply, so that's going to be 100x equals 15 times 60. 15 times 60 is 900. And then to get the x by itself, we're going to divide by 100. So we get x equals 9. So 9 is 15% of 60. The next one, you might want to just set this up. What percent of 200 is 40? So we always know that the hundreds go in the denominator of the second fraction. So what percent? So we're looking for the percent. And of 200, so 200 goes in the bottom, and then 40 goes in the top, and then same thing, we're going to cross multiply. 200x equals 40 times 100, which is 4,000, and then divide by 200, divide by 200, so we get x equals 20. And then the last one, again, just setting up those values that you can. 72% of what number? Of what number means that one is going to be x, and then this is 108. So we're going to get 72x equals 10,800. Divide both sides by 72, and you get x equals 150. Okay, moving on now to our actual lesson. This is our stats and probability chapter. So we're going to start with just some ways to gather data from a population. So the first way is going to be the simple random sample. And this is when you sample members from a larger population and they're selected by chance, and everyone has an equal chance of being selected. This is very similar to throwing everybody's name in a hat and then drawing the number that you need from the hat. So this is one of the only truly random samples that we have, like completely random. So an example of this would be that you survey random selected students at Steel Canyon. So survey randomly similar is like when I'm using the calculator to pick random people in our class. When I ask questions and things like that, there's a random number generator, and it's essentially taking all of your roster numbers, putting them in a hat, and then randomly picking them. So that is an SRS, or a simple random sample. The next two go hand in hand. This one is a stratified random sample, and that's when you divide the population into groups, and then you take sum from all, okay? So sum from all. Okay, so for this one, what we might do is we might be interested how the students at Steel Canyon feel. So what we'll do is we'll break you into strata or groups by grade level, 9th, 10th, 11th, and 12th. And then we're going to take some from all of those groups. So we might take like 50 students from each grade level. And then the next one that is similar but different is called a cluster sample. So again, you're going to break the population into groups or clusters, but this time what you're going to do is sample everybody in those clusters. So like, let's say we had freshmen, sophomore, junior, seniors. rather than picking some freshmen, some sophomores, some juniors and seniors, we're just going to pick the freshmen and the seniors, and we're going to ask everyone in the freshmen and seniors, and then the other two clusters aren't going to get sampled. So this one is the all from someone. So if you see down below, you'll be looking for some keywords to be able to do this. So this would be like if we surveyed like all kids in select classrooms, right? Because we break up our school into groups by classrooms. And then if we were doing this guy, which is stratified, we would have to sample some kids from every classroom, but we're not doing every classroom. We are going to just do some of the classrooms, and we're going to ask everybody in there. Okay. Systematic is really easy to see. You'll always be able to pick that one out because it's always going to be like every nth individual. So if you see ask every 10th person, then it's going to be systematic because it's a system. So like every 100th person who walks in the door. Or like walks into the assembly. Okay. Convenience sample. This is one of the most like a terrible thing to do because you're doing it for convenience and it isn't going to give you very accurate results. But convenient sample is simply that you're asking individuals based upon how accessible they are. And it makes the data easy to obtain, but it doesn't produce quality data. So like, for example, if I want to know how the student body feels about the lunch that we serve at our school, and I just go stand by people who are waiting in the lunch line, and then I ask them when they walk through the lunch line. That's convenient, but it's probably not going to give me accurate information because it's not including all the people who bring their lunch from home because they don't want to eat the school lunch because they think it's gross. So another one would be like you want to survey the first 20 people to arrive. That's convenient, but that doesn't mean you're getting accurate information for the whole population. You're just getting it based on people who arrive on time. Okay, and then the last one is the volunteer or self-selected, and this is just a lot of times like what you would get when you get a survey and you choose to respond to it. So you basically volunteer to do that, and it's something like if they ask you to complete a survey on Yelp or something like that, or your doctor's office asks you to complete a survey. So that is a volunteer or self-selected. You can use either term for that. So our first example asks us to determine which type of sampling method. So we want to make sure we look at these pretty thoroughly. So a researcher is studying the education levels of the population of Spain. They're going to randomly select 20 cities and survey every person in those cities. Okay, so there's hundreds of cities in Spain. So let's say there's exactly 100. They've broken up the cities into the groups. So the groups are the cities, and then they're going to take 20 cities, and then they're going to ask every person in that city, which is basically impossible. But that word every person tells us that they're not sampling some from all. They're doing all the people or every person from some of them. So this is going to be the cluster. Look for that word for cluster. Next one says a group of 25 employees are chosen out of a hat from a company of 250 people. So they put their name in a hat and then they just pick them randomly. This is going to be a simple randoms. Anytime you're picking out of a hat, it's usually a simple random sample. Okay, a company is investigating the difference in income for various ethnicities. The company chooses to randomly survey 500 people in each of the designated ethnicities. So they've broken them down into ethnicities, which means they've broken them down into groups. So this is either a stratified or a cluster. And the key to the difference between these two is they are randomly surveying 5 people in each. So this is a sum from all situation. So this is going to be a stratified. So I've taught AP stats, and one way that the students were able to kind of differentiate between the two of these is one student said, think of like a cheeseburger with lettuce, tomato, and cheese and all that. When you take a bite out of the cheeseburger and you eat the bun, the lettuce, the cheese, the meat, and everything in one bite, that's a stratified sample because you're getting a bite of every layer, right? But if you were some weirdo and you just ate like the meat and the cheese and you didn't eat anything else, or you ate the lettuce and the cheese, that would be a cluster because you would be eating the whole hamburger patty and the whole leaf of lettuce before eating the rest of it. I don't know if that's helpful, but that's the difference between cluster and stratified if you need something to help you with that. Okay, a coffee house wants to know how much caffeine college students drink in a day. They send a surveyor out to the college that is closest to their headquarters. So they're just sending someone out that is closest to their headquarters because it's convenient. So this is a convenience sample. Convenience. All right, moving on now to our next little bit, which is knowing the different types of data. There are 2 main types of data in stats. There's going to be the categorical data and the quantitative data. So categorical data is like answered with words. So the answer is a word. Okay, and quantitative, the answer is a number. So categorical, what color are your eyes? Blue, brown. What color is your hair? Purple, blonde, black. That's categorical. The answer is a word. Quantitative, the answer is a number. How old are you, right? How tall are you? What's your GPA? Things like that. Answer is a number, quantitative. So when we get to this, it says label each as either categorical or quantitative. Number of students in a class. That's a number, so that's quantitative. Population of a city, quantitative. What kind of dog do you have? German Shepherd, that's a word, categorical. Eye color, categorical. Education level, do you have a high school diploma? Do you have a GED? Do you have a college diploma? That's categorical. Your mile time, how fast do you run? 7 minutes and 32 seconds. That answer is a number, so that's quantitative. Okay, so now we're going to flip it over to the back side. And we are looking at analyzing categorical data. And to analyze categorical data, you end up using either a bar graph, a segmented bar graph, or a circle graph, or a pie graph. And so for this one, we are going to look at this, and it says use the circle graph to analyze the data. What total percent prefers a type of berry? So if we just zoom in on this, and they would like to know the favorite yogurt flavor. So all we're going to do is look at the ones, type of berry, boysenberry, mixed berry, and strawberry banana, I guess, involves a berry. So we're just going to add those 3 up. So that would be 25 plus 15 plus 20, which equals 60%. Okay. Pretty easy. I'm sure you guys can do this without this lesson, but it's nice to have a refresher. So this one right here says use the bar graph to analyze the data. How many couches in total were sold Tuesday and Wednesday? So Tuesday, there were 5 sold. Wednesday, there were 15 sold. So we would say that on Tuesday and Wednesday, it would be 5 plus 15, which is 20. Favorite cookies. So for this one right here, it says how many more girls, so make sure you read that carefully, prefer peanut butter than boys. So right here, there's 20, and then this right here is 60. So it says how many more girls, so what's the difference? So that's going to be 60 minus 20, which equals 40. Okay, moving on. Now we're doing quantitative data, and this is frequency tables. So you can see over here, this is if you just have one variable, and then this is if you have two variables. So this is like, what's your favorite leisure activity? And then somebody says, watch TV, and then 84 people said watch TV. 26 people said read, listen to music, and this is the percentage of people. So there's 200 people total. So if I take 84 and divide it by 200, that's going to give me that percentage, and so on and so forth. So this one right here, the double variable is saying, what's your favorite sport? And then they broke it down into male and female. So 13 males said baseball. Overall together, if you say men and women, 36, and that's just a two-way table. So let's take a look at example 4. It says, based on the survey, which of the following are true? There are more morning customers than afternoon. So let's look, here is morning, and then here is afternoon. Are there more morning customers than afternoon? Morning 72, afternoon 78. That is false. Okay, so morning, there's 72, and afternoon, there's 78, so that's false. Okay, moving on to the next one. Morning customers ordered more coffee than tea. So if we go to morning, we have the coffee in the morning was 54 and the tea was 18. So they did order more coffee, so that's true. Afternoon customers ordered more tea than coffee. So afternoon customers, there was 36 that ordered coffee, 42 that ordered tea, and that means that they did order more tea, so that's true. And then it says morning customers ordered tea more than afternoon customers. So the morning customers that ordered tea was 18, and the afternoon customers is 42, so that's false. The question asked us to label which ones are true, so it's going to be B and C. Okay, last one. This says Kelsey is writing an article on how students keep cool during hot weather and recorded the answers in the following table. Use the data to complete a frequency table. So for this one right here, what we're going to do is first give it a label. Ooh. So this is keeping cool. And then what are all of our choices? I see swimming. I see traveling. I see staying inside. And this will be our total down here. So we're going to be doing up top here. This is the count. And in this column is the percent. So I already know we're going to get to 100% down here. So swimming, I'm going to count the number of swimming. So 1, 2, 3, 4, 5, 6. So that's going to be a total of 6. And I can't do the percent for that yet until I figure out how many are in the total table. And then next is traveling. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 for that one. Oh, I missed one. I have 9 for that one. And then staying outside or staying inside, we have 1, 2, 3, 4, 5. So if I add up this column, there's a total of 20. So to get my percent here, I'm going to do 6 divided by 20, which is 30%. Then I'm going to do 9 divided by 20, which is 45%. And then I'm going to do 5 divided by 20, which is 25%. And you can see if I add all these up, I get 100%. And that's it for today.